Hi, good morning. Just to respect everybody's time, I'm gonna try to start on time. The phrase "this happened" and "it happened" and "it is bad" is two impressions. The first one is objective. The second one is subjective. This is bad. Our minds learn to adapt to fear, to be reactive, to get overwhelmed with amounts of data. And that's how we as human beings became. We evolved that way. Our emotions sometimes play a role in our daily activities. Engineers, electrical engineers, designers, doctors. Learning to manage emotions is something we learn as human beings. We have always explored how to manage that, how to become a better society, how to provide better jobs for people. And we ended up here. This is 2025 in the AI era. But what is that? We keep hearing every day, data centers are power hungry. AI chips are consuming more power. I was impressed yesterday at the Rumble presentation. They were talking about how many megawatts per acre. It's impressive, the amount of electricity. And not only electricity, it's water as well. Right now, people are trying to use water cooling technologies. They're experimenting. Where are they going to get the water from? How are they going to recycle it, etc. So we ended up here. My name is Ivan Ospina. I am the founder and CEO of Qubits Energy. My first data center was an AT&T data center in South America with dial-up modems. Back in 1992 was my first project. I remember my first computer with a dial-up modem. There was no Google, there was no Chrome, there was no Edge, there was no Internet Explorer. It was Gopher. I don't know if you guys are as old as I am. We had Gopher, all texts. We're in 2025, and our new Gopher is ChatGPT. We need to learn to train these models to get information out of it. It's very similar. We're systems integrators. We have been working with pretty much all the web giants out there implementing power monitoring systems and BMS systems. And we have been using different technologies. What we are trying to do here is to determine how our industry is so behind still. We're trying to work with different vendors, manufacturers, design engineering companies to make our jobs better. Just 2 weeks ago, I was having a conversation with one of our hyperscaler customers. Their engineers are resigning because they've been working so many Saturdays and Sundays, commissioning systems. Nobody can keep up with the amount of work. Nobody can keep up with the scalability that is being required nowadays to not only build, but also maintain and operate these big data centers. So we believe that AI is a great approach to help and alleviate those concerns. I am going to talk a little bit about the AI definitions. This is not a lecture. I am going to be doing more experience sharing than lecturing you guys on AI. You're probably not sure exactly who's here or not. There might be people that know more about AI than myself, but we have been applying it for a while, and I want to just experience share the different AI technologies that are out there, the different types, how we're using them, real applications in energy management systems. And I'll show you a couple of demonstrations so you can grasp tangible, actionable things that you can learn from here and take it to your daily jobs. This is a definition by a professor at Duke University. I have 3 teenage boys. And sometimes I feel engineers have the same problem with AI. This is not me. This is a professor at Duke University, a professor of psychology. The reality is that AI is not new. When do you guys think AI started? Have you heard anything, any comments? Anybody is willing to risk? Who started to talk about these things and when? Who said that, Torin? Yes. Yes. There was a professor at Manchester University back in 1950. He came out with a theoretical framework trying to promote people to experiment on machines being smarter than humans. How can we make machines smarter, or at least to the level of a human being? So he came out with a theoretical framework in Manchester University in the 1950s to try to engage humans in text-based conversations. How long ago? 75 years ago? And today is when we are really testing, when this paper came out back in 1950, right? ChatGPT is a text-based interaction with a machine. Sometimes you don't know if you're talking to a human, sometimes you don't know if you're talking to a machine or who's responding. This last Saturday, there's one TV show that I like Saturday mornings. It's on Bloomberg Television. It's a tech program, and they were talking about AI and how teenagers are making fictitious friends through AI. They're talking, they're expressing their feelings better than to their parents because they are not being judged. And it goes back to what I was saying at the beginning, that we humans experiment emotions. If my 14-year-old come to me sharing whatever, it's hard for me to control my response. Machines do not happen the same. It does not happen the same to machines. There's a couple of professors that I admire a lot at MIT. One of them is Patrick Winston. The other one is Professor Thomas Malone. They are great researchers on artificial intelligence. And they said that the computer systems that are capable of performing tasks that seem to be human, that's what artificial intelligence is. These tasks include problem solving, learning, perception, understanding language, decision-making. We need to be careful on how we divide the tasks with AI. We have a team of 25 engineers at the office just programming EPMS systems. I will say that we were able to automate the 80% of the tedious, repetitive tasks that EPMS engineers have in their daily jobs. But there is always mistakes, so I call it the 80-20 rule. 80% automation, 20% human judgment, the discernment and the evaluation of the results. That's where we are today with AI. I would say it's still the 80-20 rule. Experience. AI is learning based on experience. What is AI experience? Data. It's very different to the human experience. Different types of AI. It encompasses machine learning, deep learning, generative AI, and we can use all of them to do daily operations, to run data centers, to run hospitals. Some companies are already experimenting with AI in their softwares, in their systems. Machine learning learns to do tasks through large amounts of data. Deep learning, instead, learned by training, is capable of modeling, forecasting, optimizing. This is the one, deep learning is the one being used to control chiller valve set points or to control air handler unit set points based on large number of data, information, making decisions based on models, forecasting energy savings, forecasting best performance. And generative AI is the most popular one. I'm sure everybody here has used ChatGPT, GitHub, Copilot, Sales Copilot. There's different levels of integration that we can do with AI. Artificial intelligence, then, is a technical approach to enable more intelligent systems, to drive better decisions. Machine learning is the field that deals with computer programs that try to learn from experience. Large language models are using generative AI, ChatGPT, for example, Copilot. How are we using those? Well, before how we are using, the main limitations that we have found. Trash in, trash out. If the models are trained with poor data, then the results are going to be not the best performance. General AI does not exist. because it's biased by their own data that receive. We judge, you humans have the capability to judge, to interpret, to discern. AI doesn't have that capability. They just are computer models that search deep amounts of information to make decisions out of pre-trained models. I'm not going to go into the politics of it, explainability, ethical and legal issues. There's one very important one, the environmental impact. It's resource intense. That's the reason why we are all here in this conference talking about how we can provide power to these big data centers and these chips that are power hungry. What we are proposing, we've been having this conversation with different design engineering companies, is how we can use AI to solve the same problem it is generating. Some data centers have taken the leap of, I call it faith, on testing their own algorithms to self-performing their own data centers. I can say with confidence that they are doing pretty well. There is a book that came out by TSIA, the Technology Information Association. I don't know if you guys are familiar. They came out with a book called Digital Hesitation by TSIA. The digital hesitation is purely cultural. The technology is there, the incentives are there, but leadership has not taken the leap into transform their business models. That's the main problem with AI, is transforming many companies' business models. If you guys would like to experiment with it, there is a barcode. So we built some automation. This is just purely a demonstration. If you guys would like to scan that code and answer 4 or 5 basic questions about your own struggles with energy management, we train ChatGPT to answer the questions that you are going to have in that chat. If you would like to have the exercise, I'll give you guys just 1 minute. It should take you no more than 1 minute to answer those 5 questions, I believe. And the questions that the answers that you're going to see there are ChatGPT generated. We have been training ChatGPT for energy management with our own pre-existing models, and it's supposed to give you the specific answers to your needs. Many companies are using this approach. I'm not going to mention names here because I'm not here to promote anybody, but support. When you have the chatbots on manufacturers' website, those chatbots are typically connected to either ChatGPT or Microsoft Copilot in the background, accessing large amounts of data to answer your questions. Before we had on-call 6 support engineers in an office. We're down to only 2 support engineers. We were able to leverage those other 4 engineers to do other EPMS tasks to develop systems. Because now support is a low-hanging fruit that you can use to train, for example, either ChatGPT or Copilot to teach your engineers how the chiller plant works, how the sequence of operations for the generator's paralleling system works. Yesterday, I heard in a couple of conferences, the issue we're all having is talent. Nobody wants to work in this stressful environment anymore. The younger generation doesn't want to be enclosed in a data center 24/7 or at least on 24/7 support calls. So this is low-hanging fruit that could be implemented at your places to train it to teach your own engineers. The tool that we use behind this exercise is a tool called Mike, M-I-K-E. It's not our tool. It's a third-party tool for automation, but there's ChatGPT connected to its database in the background. You're supposed to get this. It's energy management efficiency ideas. You'll be surprised with the amount of things that you can do through automation to make your jobs easier. What we're trying to do with our engineers is the 80-20 rule. Now, if we are capable of giving them back 80% of their time because that 80% of their jobs is automated, then we have not only better performance, but talent retention is something big. Microgrid systems. I saw yesterday a microgrid presentation, very interesting, about how they are applying machine learning to optimize the different distributed resources. Now you have generators, gas, electricity, water treatment plants. I mean, our data centers are a super complex ecosystems of different technologies. Through machine learning, other companies are integrating them to not only monitor the status, but forecast demand. Through the weather analysis, how they can better prepare their facilities for solar, metering, negotiating energy tariffs. Typically, this is done through machine learning. There's different products out there. I'm sure you guys can talk to your different vendors about what's the best plan for orchestrating your different distributed energy resources. I would say that this is the part that is more advanced on AI. It's the people that are using multiple distributed energy resources needed to negotiate tariffs, model, forecast. They are the ones that are using model predictive control algorithms. They're probably more advanced. Optimizer is the key for the energy savings. These models learn to negotiate energy tariffs based on how much sun are we going to have during the week. Is it less expensive, the kWh right now, than the gas? And orchestrating all these resources is what they are doing with their softwares. Different solutions out there that I'm sure they are all available on Google. The main thing here is machine learning needs to be utilized and implemented to really help with the energy savings that the industry is looking for. In relation to tariff management, we all know that variable energy rates kills us sometimes, depending on the state, depending on the cities. Having real-time selection of resources is the best approach. Demand charge management, reduce peak power consumption to avoid peak demand charges. Air conditioning, BMS systems, are they connected to their own data? I was talking to one of the Rumble engineers yesterday. Data centers are collecting not thousands, hundreds of thousands of points that BMS systems and EPMS systems just became data collectors. If you look at the SQL database of an EPMS system that has been running for 2 years, it's gigs of information. Who's analyzing, who's benefiting from that data? So we have an opportunity for tariff management, demand charge management, self-consumption, sustainability, demand response programs, automation through these algorithms and AI. Another example, design engineers are using technology. I saw a design engineering company in California, it was a couple of months ago, training new engineers out of college on how to design electrical systems for data centers, because now it's much more simpler. This is a vendor software that implemented ChatGPT within the design engineering tool. They have models, and new people can come here to the ChatGPT prompts and ask questions about the design and about the model and get trained. These tools are already available and out there. Before, there was just the conceptual understanding of what a design is. But now they can even play with the model. They have simulation, prediction. Engineers can say, what if scenarios through AI? If I open this breaker, what will happen to my entire system? And this is what we can use to train the operators of the data centers on a daily basis. I've been in data centers where a breaker trips, and the day-to-day operation guys struggle sometimes to find the root cause, because the EPMS systems became just data collectors. So we need to evolve them to apply all these technologies that are available to not only teach them better, but help them react better. Instead of emotion-driven decisions, it's data-driven decisions through AI. One thing that we're trying to do is get the design models and implement it all the way to the end to the EPMS implementation in the field. In construction, what are the tasks that from design to implementation are followed to implement an EPMS or a BMS system? A design engineer designs their system. They create AutoCAD drawings, whatever drawings, and they put it on PDF files. Those PDF files are sent to the GC to be sent out to different vendors to bid. Those guys read those PDF files and duplicate the drawings in their own tools to present the proposal. The proposal gets sent. The proposal is approved. Then they pass on those same documents, PDF files, to the programmers of the EPMS or BMS systems to replicate the sequences that were written in those PDF files. Now we have written 3 times the same specs. Design engineer, the sales guy, now the engineers in charge of the job. What we're trying to do is get those models and generate a framework, cloud-based framework, to make it the basis of the implementation in the field. What is commissioning level 4 in a data center? It's still embarrassing. Commissioning level 4 is commissioning engineers sitting next to the EPMS or BMS vendors or other vendors, taking screen captures of the software to make sure it is accurate and getting alarms and is working. So we're so behind in the technology still. We have an opportunity to improve all the systems from design to commissioning, automatic documentation, automatic creation of screens. In big data centers, just something as simple as moving a Starline meter in a data floor, somebody has to go and manually change not only the screens, but the databases, the IP addresses of the Starline meters. We're not using advantage of the automations that AI offers. So that's what we're trying to do, and there is an initiative by several different companies. It has ABB, Eaton, Schneider Electric. We've been meeting with other system integrators of these companies at a higher level to see how we can solve the scalability problem. Different data centers are building multiple phases at the same time in different campuses. There's no one company that has enough engineers to provide the support for that type of construction speed or scalability, just commissioning. If you see commissioning level 4, it's a lot of engineers in different places of the data center just taking screen captures, while others are at the office making fixes to bugs that they are finding during commissioning, overriding the changes that the engineers are finding in commissioning. So the opportunity is there. There is already some EPMS systems and BMS companies out there trying to leverage from design to commissioning to avoid those type of mistakes. So I guess I encourage you guys to look into that as well. Talk to your design engineers, because there's companies that are trying to do this different to promote and allow scalability. Natural language processing. You can ask questions to your EPMS systems in real time. List the equipment below 1 kV. You get the list, you get the report. What type of isolating device could be used to isolate a fault? Simple human language questions could be asked to your models, to your EPMS systems, to better, or let's say not to better, to not confuse your own engineers. Another example that we have been trying to build, this came out of necessity working with a web giant. These guys were building multiple campuses throughout the US and multiple phases at the same time. We needed to comply with standards, standardization. These guys standardized the list of points, the screens. But having multiple engineers working even on one campus was creating challenges, because one was doing the programming in one way. Another engineer working on the same campus was doing it in a different way. So instead, ChatGPT was trained to understand the structure of the graphic pages and how the databases with the list of devices, with their own point list, not our point list, with their own point list, it was trained. Something as simple as validating if KWH was part of the devices database. Sometimes I've seen those in data centers. I'm sure you guys have seen on EPMS systems. Sometimes The engineer just forget to put the kWh measurement coming from the meters. Those are common mistakes, kW. Or voltage A, B to C. When you have human-centered in this type of databases, you can make mistakes. Instead, if you use these technologies, those mistakes are going to be pretty much gone. We just need the programmers to validate that those profiles are getting the data and the screens were created in a correct way. Through prompt engineering, these systems are being built nowadays. And there's companies out there, EPMS and BMS, in a rush to transform their old way of doing things, having engineers creating screens. How do they do it at the office? They get the PDF files from the design drawings, and they just start drag and drop, drag and drop, drag and drop. It's a totally manual process that leads to many mistakes. When you are building an entire campus, EPMS or BMS, you're going to find at least a higher percentage of mistakes. But we're trying to automate all this with these technologies. That is available. I encourage you guys to allow your engineers to experiment with that. You guys are not going to break anything. And these technologies, the paid subscriptions to these AI technologies are not exposed on the web. We pay our own internal subscription to ChatGPT, and that information is not publicly available. It's our own database. So that avoids the cybersecurity or NDA concerns. For us to capitalize on these emerging technologies, we just need to jump and allow our engineers to experiment with it. Even ourselves, we have to allow ourselves an experiment with it. When we challenge our own engineers internally, when I find engineers just creating graphics, drag and drop, doing repetitive, tedious tasks that can lead to mistakes, or just creating device profiles in a database of any BMS or EPMS software, our challenge is, if you find yourself doing these repetitive tasks, how we can automate it. There's many different tools out there. Challenge your engineers to automate their repetitive, tedious tasks. There's different tools out there already that made it very, very, very easy. Even Microsoft Copilot offers a way of creating. If you guys are familiar with something called Microsoft Visio, you can even create flowcharts, and those flowcharts are plugged into Microsoft tools that make them a process. We don't even need coders anymore, the beginner coders. We have better quality of code generated by these tools. We just need to teach them to use these tools to write code faster and more efficiently. Same thing in the data centers. Engineers do not need to call the manufacturer to build a custom report anymore. Through these tools, they can just ask, using natural language processing, ask questions to the databases directly to give you the data. Once you train those models, there's low-hanging fruit there to be more efficient. I just brought it as an example. Is this book called the Energy Management Handbook. I read it 10 years ago, and I understood half of it. I am not a design engineer. But even design engineers, how are you going to put all this information into an energy management system that is not just self-sustainable, but has to comply with sustainability metrics, has to comply with government regulations, has to manage the complexity of multiple distributed energy sources, hundreds of thousands of points? So the answer to all these challenges in the new generation of data centers is the use of these technologies. Some companies already started experimenting. So change management, employee development. This allows your employees to have more fun jobs, research and development, have them experiment with the technologies. And they will have probably a better job, and they will resign less. And we will find more talent. Because before, instead of having engineers sitting at buckets, commissioning level 3, commissioning level 4, we will have systems that are providing more accurate data, more accurate analysis, more accurate reports, even to commissioning engineers. I'm going to stop right there, and I am going to allow time for questions. Oh. How many of you are using already AI in your daily jobs? Probably 20, 30% of the room. So there's a huge opportunity for the ones that are not using it to explore and experiment with it. Well, I don't have questions, so yes, go ahead.
How do you see that, I guess on the commissioning side of things, how have you seen it being used there?
On what side of things?
Commissioning?
Commissioning. The sequences of operation is what commissioning engineers are validating. So training models for commissioning with the design documents, the AI can be trained to determine if an alarm make it accurately or not, depending on the sequence of operations. That's one basic example. I've been having this conversation with a couple of design engineering companies, and one of the commissioning companies that I see a lot in the data centers is how can we get the design in a way that can be exported to the commissioning engineers, so you don't have to even learn the sequences of operation, you just need to understand it. So you can train these models to give you the commissioning reports automatically that said if a specific sequence was triggered, if the data and the alarms and the sequence that needed to happen was executed. This happens at hospitals. Hospitals are required to exercise generators for 30 minutes twice a month, some of them, or once a month with 30% load. In the past, the technicians at the hospitals were running all over the ATSs with radios. They have technicians at every ATS and a guy that was going to trigger the sequence at the generator to shut down the utility. All right, I'm going to start. And the guys were manually measuring the transfer time. How can you, with a radio, measure if an ATS made it under 20 milliseconds or not? Did it transfer? Yes. But is it comply with all the conditions? So tools have been built, for example, for hospitals to help them with those type of things. Because all the statuses, all the temperatures from the generators, all the electrical data from every device in the network is being captured. So same thing at a commissioning in a data center. You're commissioning all the statuses, all the electrical data, all the temperatures, everything that you need to have a system tell you if something performed according to a sequence or not. So that's how I am not aware of a commissioning engineering company totally automated, but there's a couple of them that are already experimenting with design engineering companies, integrating both into one, and that's through MLL. Is how can you automate? Commissioning engineer, how many commissioning engineers is level 4? Is the BMS, is at least 3 or 4 BMS guys, at least 3 or 4 EPMS guys, depending on the size of the data center. And the EPMS guys are just taking screen captures. So that's low-hanging fruit to automate. Thank you for your question.
Yeah, one of the things we're really focused on is demand management. I noticed that in some of your slides you had demand response programs, and as well as this little this survey I took, it suggested automated demand response. I'm just curious to know some of your customers, how are they participating, data centers participating in demand response despite some of the SLAs and customer requirements for redundancy? Because obviously you're curtailing your load, and if you're going off-grid to your redundant backup generators, then you're no longer meeting that SLA for uptime for redundancy for whatever your customer may be requiring.
Right.
Are you seeing any data centers actually participating in demand response programs?
Not in the US. Outside of the US, yes. In the US, very few. I can think of one customer in Miami, in South Florida, just because of the vulnerability of the grid because of the hurricanes during the hurricane season and all those things. So they forced the utility company to negotiate rates to use their own generators on site. So this is a typical demand charge management where they guarantee that they are not going to exceed certain demands in the summer for the hurricane season, so they don't overload the grid. That was one, but it's because of the conditions of that state in the south part of the state. It's very niche. This is being done a lot in Australia, for example. We have a customer in Australia that they have all the tariff management based on demand response. And what they promised is there was a microgrid system that was implemented to automatically negotiate tariffs in real time based on the conditions of the existing conditions in the data center, but this was in Sydney, Australia. In the US, I am not seeing that much. It's very niche approach.
Yeah. So other than maybe geological, environmental factors, what would potentially have to change in order for this to be a more viable program for data centers?
The thing is, in data centers, what's the only load that matters? The IT load, right? Just do whatever it takes to not drop the load. Because of that approach, there's not really much opportunity there. I have seen that more on industrial facilities. We have a couple of projects in Tennessee that is totally, it's a regulated market anyway, but what they're trying to do is to avoid the peak demand, so they pay less. So industrial facilities is low-hanging fruit for them. In data centers, just because of the nature of the load, I am not seeing much that approach. And I would appreciate if somebody has a different opinion. I'm just talking about my experience. If somebody here is doing that load management program and want to share their experience. My experience was with this data center in South Florida. If you guys have a different one, it would be great to share it.
So in your model training for, let's say, using a natural language, right? How much of the hallucination you actually see when you get the answers back? How much what? Hallucinations in the AI models. Because the AI models tend to have hallucinations, right? So how do you guarantee the hallucination doesn't kick in?
So what we train it for in that space, in a particular case, we train it to understand the format that certain graphic files need to have, either the JSON files or HTML files. So it's a very specific approach, training it with a specific code for graphic data. Having said that, when you train the models that way, it has much less hallucinations or bad responses. You still have probably around 10% of mistakes. And that's what I was saying, the 80-20 rule. Our experience has been around 80-20. 20% of mistakes, 80% of good information and feedback. But that's our own experience training on scripting and TGFL files to create automatically graphics based on PDF files that have electrical controls.
The distillations actually be better to improve the accuracy.
How to do that?
So if it's distillation, right, to distill data, then cycles will help to get to, not say 95%, that's probably the limit.
I believe so, but the way we do it is human feedback. Our engineers provide the feedback to say, from line 20 to line 10, there is an error, there's way to tell it what the errors were. So we learn from those mistakes to not do it again. But the way we have done it is through human feedback. In relation to data, this is interesting because I am a computer engineer by education, but I needed to hire a data scientist for an office to really get the large amounts of data. Just one customer allowed us to experiment with around 75 gigas of information that the UPMS system captured. I didn't even know where to start. So data scientists are becoming a key role into all these operations. Data scientists, I mean, my 17 years old just took a data science class in his senior year in high school. So we're starting that early to train them to analyze the data. Data scientists are capable of looking at data. You guys seen the movie The Matrix, like in the 90s? That's a data scientist to me. They're guys that look at ones and zeros and a lot of data and make sense out of it. But data tells a story. This is what he does. All this data that we have in the database tells a story of their performance, a story of their shortcomings. Something as simple as SER, sequence of events recording. A lot of data centers have sequence of events recorders, and engineers have a hard time finding where the event started. Was it upstream? Was it downstream? Because the alarms, there are hundreds of alarms that are generated with a medium voltage relay trips, or a load breaker or an RPP trips, where to start the analysis with so many thousands of points. This is low-hanging fruit to train AI to analyze that data and put it in the sequence based on the timestamp, put it in the right order. So engineers or even technicians running the data center can easily say, okay, the root cause of this issue was X, and it was because of this and that and that. So AI is a way to help these technicians with those large amounts of data. But again, sometimes mistakes are going to be found, and that's one of the shortcomings of AI. It doesn't find its own mistakes. It has to be feedback, either by itself or by human. But when AI trains itself to correct mistakes, typically other mistakes, and that has been our experience. So I prefer humans providing the feedback to train the mistakes. Any other questions? Who runs here data centers? Who's on day-to-day operations of data centers? Day-to-day operations. Are you guys using any of these tools at all? You're not alone. Technicians are afraid of using these technologies for themselves. It's not hard. Force your vendors to look into these technologies. When you have engineers generating manual reports for KW on an EDMS system, it shouldn't be that way anymore. There's better ways. There's companies getting together, having this conversation. That's why we're going to different conferences. Here we have other vendors also talking about the same problem. How can we fix the scalability issue, right? How can we better manage the resources that all these AI data centers are using? It's huge. It's a huge amount of electricity, right? Before it was 30, 40 kW racks. Now it's 100, 150 kW racks. Multiply that by thousands of racks in a data floor. Engineers having the stress of not dropping those loads, monitoring hundreds of thousands of points. So I encourage you guys to look into this as a holistic approach. Reach out to your vendors, to your design engineers. We all have the same concern. How we can use these technologies to better improve your operations on a day-to-day basis. Hospitals, industrial facilities, we are all having the same common problems. So I think we have an opportunity to come together as an industry and solve it with these technologies. My main concern is how can I retain my 35 engineers? Because these guys are working Saturdays, Sundays, getting alarms, monitoring how many different data centers throughout the US and even Latin America. The only way is to provide them with the technologies to have a better life. Because at the end, we're all humans, right? A job is a job. How can we help them and retain the talent is to provide them technologies like this, to have a better sense of their jobs.
Just one more question, curiosity. So now you're using the AI, right? So you're building the model using that. So what is the overhead now that you're taking loops to the data center by using the machine locals to run your software?
We try to use it, so there's different ways. This ChatGPT algorithm that you see here, and this is not our software, this is somebody else's software. This software runs on local machines. There's a ChatGPT instance running on your local machine. So not necessarily everything needs to be cloud-based to run it. You can do automation and implement ChatGPT databases in a localized way. So you reduce the burden on the data center. They saw us using that approach. I would say the increase, we haven't measured that for our own company, but the increase in AI loads when they are executing is about 25 to 40% more resources. This is public data available. That doesn't mean that these software do that, but it's around that value, the people that is doing the research. I had this conversation with one of our co-location data centers. They are running AI algorithms for other web giants. It's a co-location data center. They needed to increase 35% of their electrical capacity, like in 2 months, in order to support expansion, to support these new loads. Does the utility support that? The conversations with AI is not only us, It's also with the utility companies. Do they have the capacity to support the regions where you plan to expand or build your data center? What's happening here in Northern Virginia? What's becoming the next? Everybody's going to Ohio now. The people that were told no here in Northern Virginia are now moving to Ohio, and that in the last talk to the utility company in Ohio for the same thing. Once Ohio said, okay, I'm done, when are they gonna go, right? So this has a solution through the same technology, and I totally believe as a computers engineer that technology is a solution for these same problems. We just need to trust it. Yes, it has mistakes, 80% of mistakes, but I think it's worth it to give it a try. As engineers, come together as an industry to refine the process. Those automations, procedures. Well, thank you very much for your time. And